We did example number 1 yesterday. So then that would just take us to example number 2. So we defined all these things yesterday. And then we had just gotten to this one, and then we're going to do number 2. So unless we're told otherwise, that's where we're going to pick off today. And then you can see there's just a handful of questions here. There's just 4. We'll do them. The next page is going to be your homework. Just 5. Whatever time we have remaining, we're going to talk about these together because some of these are pretty hard. Like if you had to sit on these on your own, that would keep you busy for a little bit. So number 2, let's pop up here to number 2. And then let's talk about some things that we would have talked about yesterday, since we've now had a little break in the action, where we talked about how if I give you these tick marks, that's telling you that those two sides are congruent. They have the same exact lengths. So if I told you this was 10, then we could conclude that this side would also be 10. Now, we don't know that, so we don't want to add that in there, but that's what that would mean. What we were also then told, one of our little theorems above, so if you kind of backtrack to a previous page, this one right here, if two sides of a triangle are congruent, so let's mark these two as congruent, so it looks like the one we're dealing with, then the angles that are opposite of them are also congruent. So if I ask you what angle is opposite of that side, that would be this angle I. And then if I ask you what angle is opposite of the other congruent side, that opposite angle would be J. So those angles are congruent. The way we mark angles congruent, we use arcs. So if I put a single arc here and a single arc here, that tells us angle J and angle I are congruent. That's what we're looking at with this problem. So this side here being congruent to this side here means their opposite angles are also congruent. So that means this angle is congruent to that angle. That means, like I said here, 10 and 10, they're equal to each other. Same thing with our angles. So this little 3x plus 5, that angle has to equal the angle that's defined by 2x plus 10. And then that's our equation that we can use to solve for x and then also solve for y. So if I now solve this equation, we're going to subtract this 2x over. Subtract your 5 over, and what we find is that our x is 5. Okay, so that's one of them. But still, you're multiple steps away from being able to figure out what that angle y is. So what we now have to be able to do, and this is the story with all of these problems, that's why you don't get a lot of homework with this, because each problem takes some time. What we now need to do to figure out what our angle y is, all right, thanks, Cameron. We're just on the next page, or the next problem that we left off yesterday. Now that we know that x is 5, what I'm going to do is I'm going to go here. I'm going to let x be 5 in that expression, and I'm going to let x be 5 in that other expression. That will then tell me what each of these angles are. So if we do that, so I'm going to take this 3x plus 5, and then this is, we don't name that. If I do that 3x plus 5, and I let x be the 5 that we just figured out, then what we now find is this is 15 plus 5, that angle is 20 degrees. So I can now come to this angle and know that this is a 20-degree angle. I could have done the same thing here. Like if I wanted to, I could plug in 10 right here, or a 5. I'm not, hold on a second, wrong one. I could take this x value of 5 and I could plug it in, do the same exact thing. It'll totally work, but aren't these angles congruent? So whatever this angle is, this angle has to be the same. So once I know that this angle here was 20 degrees, this angle here must also be 20 degrees. So then that allows us to say that that's 20 degrees. Even though the problem doesn't ask for that, you have to figure that out before you're going to be able to figure out what your y value is. So now, recall yesterday and the day before, in a triangle, we always have 180 degrees within a triangle. What we're going to do, we've already got 20 here and then 20 here. So if I get rid of those two angles, what that tells me is there are 140 degrees remaining. So that has to be the degree measure of this angle right there. So the missing angle has to have a degree measure of 140 degrees. Notice how it's defined in our little diagram here as a twice y. So that's our second equation that gives us y. That angle 2y, we now know has a degree measure of 140 degrees. We can set those equal to each other, divide, and then we can now figure out that y isn't a degree necessarily. That y has to be 70. All right, so x is 5, y is 70. Those are our answers. Okay, not easy, not easy. All right, next one. Yesterday we talked about these words, so let's rehash this. Scalene means no sides are congruent. Hey, Mr. Kubis, could you do me a favor real quick? If you got something to write on, can you figure out how we messed up number 4 maybe? My guess is one of these is a y. So before we get there, can you see if you could figure out how we could change that so number 4 will work? All right, so number 3, scalene means no sides are congruent. Equilateral means all sides are congruent. Isosceles means 2 and only 2 sides are congruent. All right, so the question is, what is this? And if we were in a geometry course, one of the first rules of geometry is we never assume by looking at a triangle. We never just look at a graph and assume what's true. So we wouldn't want to look at this and say none of them are congruent. It looks like maybe these two are congruent, but we don't want to assume that. So scalene, no sides. Equilateral, all of them. Isosceles, 2 sides are congruent. What you're also told is the perimeter of this is 32. So the old idea of perimeter is if we add up all the sides, that's your perimeter. So if our perimeter is 32, that means I should be able to do the side of 10 plus the side of 2x minus a 3 plus the third side of x plus 7. When I add all of those up, if our perimeter is 32, then this has to set equal to 32. And then that's how we can now solve that equation, or at least get our x value. The algebra with this, we need to be pretty good with solving equations. And notice how we have like terms here. We have 2x and a 1x, so we have 3 x's. And then I have a 10, a negative 3, and a 7. So what is that? So that's 14 when we add up those constants. And then that equals 32. Now we're ready to subtract that 14 over. Divide, and what we would find then is x is a 6. When we do our little quiz on Friday, I think I mentioned yesterday that we're going to go over this today. We'll review tomorrow, quiz on Friday. Make sure you answer your question, because a lot of these require you to solve for x, but the x has nothing to do with our answer. You're not going to put 6 in the answer box on Friday. What the question is asking, is this scalene, equilateral, or isosceles? Well, we know this side is 10, so let's take this x value of 6, let's plug it in here. Isn't 6 plus 7 13? So we now know this side is 13. Take this x value of 6, plug it in right there. 2 times 6 is 12, and 12 minus 3 is a 9. So if you look at our 3 sides, notice how none of them have the same lengths. Because none of them have the same lengths, you would then state that this triangle is a scalene triangle. Okay. Okay. Hopefully that makes some sense. Okay. Okay, perfect. So this one, bottom one. All right. So if you look at number 4 here, we messed up when we wrote the question here. So what I want you to do is to go to this x on the bottom. Notice how the question is asking you to solve for x and y. There is no y in this problem. So go to that x and make this a y. So it should be y plus 8. All right. Then the question is now asking you find x and y if we know that this triangle is an equilateral triangle. So now equilateral means all sides are congruent. So I'm going to mark these. That means we could put 1 tick mark in all of them. And all the sides then are said to be congruent. So we could, if we wanted to, it won't do us any good, since this side here and this side here are congruent, we could say that y plus 8 equals 3x minus 3. But notice how we have two different variables here. That's going to be hard to solve for either one of them. So we don't really ever want to do that. It should just look weird if you're solving an equation and there's an x and a y in that. So while we could do that, it just doesn't do us any good. But since it's equilateral, then this side here would have to have the same length as this one over here. So this 3x minus 3 would have to equal 15. But then wouldn't this side also have to have a value of 15? So then the y plus 8 would also have to be the same as this 15 side. And then just like that, you have your two equations that will allow you to solve for x and y. Okay? All right, so then from there, this should be easy. Add your 3. So 3x equals 18. Divide, and then x is going to be a 6. So that's our value of x that we needed. And then now our value of y, just subtract the 8 over. And then y is going to equal 7. All right. Ooh, that's weird. Now, those are the notes. That's kind of what we wanted to do. That's the new stuff. Just the types of triangles, isosceles, scalene, equilateral. And then knowing if we have an isosceles, those two sides that are congruent, the angles opposite of them are congruent. Your homework are the next. So the next page here, you're going to do 1 through 5. But I think you would find right now, if I turned you loose on all of these are pretty hard. So we're going to do, we'll probably get through at least 1 and 2. We'll see where we're at with number 3. So 1 I'll do together, and then I'll have you try number 2 and see if you can figure this out. So for number 1, it says solve for x, and then find the measure of each angle in your diagram. So with this, we always want to kind of make a note of what we have marked. So if you notice, we have a tick mark here, and we have a tick mark right there. So what we just talked about, if these are our congruent sides, so congruent sides, then the angles opposite of them are also congruent. So what that would mean is the angle over here and then the angle over here, those have to be congruent to each other. That allows us to now set up an initial equation where that 3x minus 11, so this angle on this side, would have to equal this angle over here. And then that's going to allow us to now figure out what our x is. So to solve this, we're going to subtract our 2x from both sides. And we get 1x minus 11 equals a positive 11. Add this 11 to the other side, and then what we find is that x equals 22. So that's one of the things we wanted. So we definitely want to solve for x, but I also want you to find the measure of each angle in the diagram. So if this is 22, that's one of our things. Let's say I now want you to find angle A. So angle A is defined right here as 3x minus 11. And we now know that A, to solve for it, the x value is a 22. So you're going to do 3 times 22, and then minus 11. So this is 66 minus 11. That should be 55 degrees. So we come up here. We now know that this angle right here is 55 degrees. So that's one of our answers. The next angle I want you to write down is angle B. And so if I now ask you to find angle B, angle B is easier, at least it should be. We could, if you want, take this 2x plus an 11, and you could take the x value of 22 and substitute it in. Totally fine, definitely going to work. However, it's somewhat unnecessary because the whole idea of these two angles have to be congruent. So as soon as I know that this one is 55 degrees, this angle here would also have to be 55 degrees. All right, so angle B would also be 55 degrees. And then the last angle that we need is angle C. So we now want to figure out what is the degree measure of this angle. This goes back to something we did a few days ago when we were introduced to this, and we talked about a little bit yesterday as a review. Within a triangle, so if we now look at this overall triangle, we always have 180 degrees in a triangle, always. So if I want angle C, all I am missing is angle C. This has to be 180, and then let's subtract 55 and 55, because those are the two degree measures of the other angles. Angle C would be whatever remains after we subtract those away. All right, so when we do that, 180 minus the two 55-degree angles, that leaves 70 degrees left over for angle C. And then I'm not sure why we didn't ask for Y. Let's say I ask you for angle Y. Now that we know this angle is 70 degrees, we could figure out Y, because Y needs to equal 70. Divide that by 2, and then we would know that our Y has a value of 35. Okay. Number 2. Try number 2. I want to give you a minute or two, and then we'll kind of see this. Like I said, even watching us do it doesn't help you problem solve and put connections together until you really start trying this yourself a little bit. So try number 2 here. See if we could work our way through with any thoughts about how we could figure out what is X and then what is Y based upon that triangle. All right, we'll give you a minute or two to try that. All right, anybody have any thoughts about how we could get this thing going? Anything worthwhile we want to throw out there? Anybody? All right, so nothing to share, nothing we can conclude out of any of this. Are we sure? Oh, do we? I did not see that. Okay, let's see if Dahlia saves it, because I was about ready to put this into a little Canvas quiz real quick. All right, what do you got, Dahlia? Say that one more time. The sides are what? Good. Okay, good. So here's what Dahlia is saying. We know that these two sides are congruent. So what we were just going to say is that, or what we just used in the previous problem, those angles are congruent to each other. So what she's saying is we really can't do what we did in the last question. In the last question, I would have had you take 3x. and set it equal to y plus 7. That's a valid thought. It's 100% correct, but it just doesn't do us any good. Like, how are we going to solve this if there's two different variables in here? So that's kind of what Dahlia is saying. What we used last time won't necessarily work for this one. All right, so good. But that's the correct mindset, is that those should be equal to each other. It just doesn't get us anywhere for this particular problem. Andre, what do you have to add, bud? Good, Andre. I don't know if it's obvious for everybody, so let's slow that down a little bit here. Say that one more time. Okay, stop right there, because that actually is exactly what we want to talk about. Don't we know this is 90 degrees? And in a triangle, don't we have 180 degrees overall? So if this angle is 90 degrees, let's get rid of that angle. We have 90 degrees remaining for this angle here and this angle here. Don't those together have to be 90 degrees? Because we've already used 90 in that top angle. So then what he said, go Andre, what did you now say? After we know those are 90, how did you get these two angles to be what you said? Good. So what Dahlia had said was true. We know these are congruent. So let's mark these congruent. The way we mark angles congruent are with arcs. So draw an arc here and draw an arc here. These are congruent angles. That means they have the same degree measure. Well, if they both have to add up to be 40 or to 90 degrees, Andre is getting them to be 45 because he's just taking the 90. And if they're the same angle and they add up to be 90, all he's doing is cutting that in half. Don't they both have to be 45 degrees? So this angle is a 45 degree angle, and this angle is a 45 degree angle. So that's what Andre said right away when he popped in. Those have to be 45 degree angles. So that's great. Now, we still got a little work to do, right, Andre? So now how can we use that idea to get X and Y? Do you know? Good. So this was defined as 3x, and we now know that must equal 45 degrees. Same over here. This was originally defined as y plus 7, but we now know that that must equal 45 degrees. Now we have two equations, really simple little equations here that we can solve. So the work is easy, but we got to understand a lot of things to get to this step. All right, so kind of Dahlia and Andre kind of together, that's where we get. Divide by 3 for this one, we find x to be a 15. Subtract 7 over in this one, and then we get our y to be 38. All right, good, you too. And you saved everybody from having to take a little quiz on this. All right, good. Maybe we should give him extra credit for that, Mr. Kuwitz. Yeah, it's not a bad idea. All right, let's try to get one more done here. Number 3, same thing now. Although I want you to add something. I realized first period, I don't think I talked about it with you guys either. Notice how this is an equilateral triangle. You have tick marks here, here, and here that all match. So that means all 3 of these are congruent. So that's an equilateral triangle. What I want you to add to your notes, so if you can flip back to the previous page, I think it's on the previous page for you guys. So when we talk about an equilateral triangle, one of the things we want to know, another theorem, is that an equilateral, oh, that's big. Hold on a minute. An equilateral triangle which is what we have in the problem we're going to do here in a second, is always, so 100% of the time, so it will always be an sounds weird, especially when I say it slowly, equiangular triangle. So basically what that says is, if I have a triangle and I tell you all 3 of the sides are congruent, what that then guarantees us is all 3 of the angles would also have to be congruent. You want to know that to get this last problem started here. All right, so have that down. Make sure we know that. So now let's revisit number 3 and the homework you're going to submit for me. This is an equilateral triangle. So now, real quick, take another minute or two. And again, try to think this through. We're going to be here on Friday on a quiz where you're not going to wait for me to kind of then show it or somebody to throw something out here. We got to be able to put some connections together. You don't have any measurements at all, right? Like I don't give you 1 degree measure, but somehow we should be able to figure out what this angle over here is equal to. So the practicing of that thought process of putting things together is pretty important. So see where we can get with this one. See if you can get at least something started. Like what does it mean? What could we do? What could we use? And see where you end up. All right, so I'll give you a minute. Go. Okay, anybody got something that we can get started with here? Yeah, Dahlia. What do you think, Dahlia? Good. So while we can't use this just yet, that's going to be a pretty key idea, is that this line on the bottom always adds up to be 180 degrees. So that 100% is something that we're going to need to use here in a second. All right. What else could we write down that we can conclude by just looking at this? Jacob? Good. There's 180 degrees in a triangle. Notice how there's 1, 2, 3 angles. So we said you're going to divide that by 3. So then we would know for sure that each angle, if I can, would have to be 60 degrees. So this is 60, this is 60 degrees, this is 60 degrees. And then now Jacob and Dahlia's ideas together move us along to the next triangle. Because if we now look, this angle here, so this 60 degree angle, and this angle here, using Dahlia's idea that this is a 180, don't we have a straight line formed by those 2 angles down here? All right, so what would that have to be, Dahlia? Oh, I'm sorry. So do you know what would this yellow angle have to be if 60 and this add up to be 180? Did you get there yet? Good. So that would have to be 120 degrees. So that if I did 120 and 60, then I have 180 degrees, like she said, for that straight line there. All right. Good. Now we're at least into the next triangle. And then now we're going to use these ideas that we talked about in that last question. So if I now, let's highlight this triangle in yellow. So now let's look at my yellow triangle here. Notice how this side here with 2 tick marks is congruent to this side here. So aren't their opposite angles congruent? So don't those 2 missing angles in the yellow triangle have to have the same degree measure because they're opposite of the congruent sides? We have 180 degrees total in a triangle. So now look at the yellow triangle only. We know these all have to add up to be 180, but didn't we already use 120 of those degrees right here? So there are only 60 degrees remaining for the two missing triangles or two missing angles in the yellow triangle. Since those are congruent, don't they have to have the exact same degree measure? So now we know each one of those angles, if they're congruent and they add up to be 60, would have to be how many degrees? Dahlia? Good. Would have to be 30 degrees. So this is 30. That is 30. And then like Dahlia, she had a premonition early. She talked about it at the very beginning. This is also a straight line, right? So these two angles right here have to add up to be 180 degrees. So the yellow 30-degree angle with the missing angle X that we're trying to find, those two together better add up to be 180. We already have 30 of that. So wouldn't now angle X, go ahead and finish this off, Dahlia. What would X have to be? Good. This would have to be 150. So that if I did 150 plus 30, that would give me my 180. So X would have to be 150 degrees. Okay. All right. It's good stuff. It makes you think a little bit. It's kind of like a little puzzle where you got to have the first piece to get to the second piece and the third piece. Like here, we just had to go systematically on down the line using 3 or 4 different theorems along the way. Okay. All right. So good job. Thank you. All right, so with that, homework should then be easy. You're going to do number 4. You should have all 5 of them done. So let me not just say number 4. So you're going to do number 4, and then you're going to do number 5. All right, and then upload all 5 of those.